What's up? What's up, folks? Y'all know what time it is. I'm back on here live again, about to do another coding challenge. Just trying to make sure everything's set up straight. What's up, Photo Logic? What's up, man? What's going on? Darius, man, y'all go follow him, check him out. Just waiting for people to join, but yeah, I'm on here doing another coding challenge. This one's gonna be an easy one, but this one kind of tripped me up a little bit. I saw this dude on Instagram. I think his name is Greg Hogg or something like that. He did this challenge. He posted this challenge this week sometime, and I was trying to do it in my head, and I was getting mixed up real bad. So I was like, well, at the end of the week, I'll go live and try to do it in front of everybody, and we'll learn together, or y'all at least see how I was struggling with it and the mental loops I had to jump through to kind of solve this one. Because it's kind of like multi-step, multi-solution. So yeah. So I'm gonna give it a little time. What's up, Levi Dev? What's going on, man? Yeah, I think I'm gonna go ahead and start this thing off. Yeah, it's a problem on LeetCode.com called minority element. It's an easy problem, supposedly easy. And it goes as such: given an array of nums of size n, return the majority element. The majority element is the element that appears more than n divided by 2 times, where I guess, yeah, given the array, the size of the actual array, so however many items is in the array, this element appears n divided by 2 times, so more than half the time. You may assume that the majority element exists in the array or always exists in the array. So that's a big part of the problem that's gonna be very important. So I think one thing with this problem is, like, it seems super simple, but like literally everything they say here is important, which is always mostly the case, but sometimes it seems to matter more than other times. So let's try to figure this out. Let's try to work through this. Appreciate people joining. This is the problem. We're on LeetCode. Hey, we're about to get this going. So, majority element. So they gave a little example here. Example 1, there's nums. So I guess the size of nums would be 3 in this case. And the output is 3, because this 3 occurs more than half the time in the array. And then they have this example here with all the 2s and 1s. Obviously, the 2 is what occurs more than half the time in the array, and the 1 is kind of like the minority here. And so 2 is the output, and the constraint is, yeah, of course, n equals the length of the array that you get, and then n, I guess the length of the array will never be more than 5 times 10 to the 4th power, which is a lot, but it's a reasonable constraint. And then they're saying the numbers in here can be negative or positive 10 to the 9th power. I think in JavaScript, we're fine with these constraints. I don't think I have to worry about any weird things happening with the numbers here. But that's something important. These constraints, of course, if you're in an interview, these constraints make a lot of sense. And then these, or they are very important to your problem. I'm sorry. So follow up here is, could you solve the problem in linear time and in big O of 1 or big O constant space? Meaning that the space you use is constant as far as like the data structures that you use to hold some amount of data as it relates to the size of our input. So it's not that we can't use any variables or any type of variable, any type of storage, I guess, altogether, but it just means in relation to how our data scales with the size of our input, we're basically, can we do the problem with big O of 1 space? But I'm gonna ignore this for now because this is like a follow-up that maybe an interviewer may ask. But the first thing they'll probably ask is just how to do this problem at first. So if you ever been with me before doing these problems, I'm looking on TikTok. Somebody has a solution. I'm not even gonna get to that part yet, but if you ever been with me on here doing these before, you know I like to think through the solution first, how I would do it in my head, and then try to translate that to data structures and algorithms that I'm familiar with, and try to translate that to a solution and talk through that. That's what you would need to do in an interview. You at least need to talk through it at some point with the interviewer to say, hey, is this okay? Does this make sense? Because they may be able to help save you if you're going down the wrong path. So it's always good to not just jump right into the code, but to like at least think through your solution, maybe even do some pseudocode at times. But interviews are like time constrained, so you also don't want to go too crazy with trying to do a bunch of pseudocode before you jump to the problem either. You want to don't talk too long, give the interviewer a chance to stop you if they're trying to help you not go down the wrong path. So that's kind of my thinking behind it. But how would I do this in my head? So it's pretty simple. This is an easy problem. It's supposed to be a level of easy. So if I'm trying to find a majority element, the element that is in the string more than half the time, then I would simply count. I would say I would get 3, and I would say, okay, I got 1, 3. I would loop through this array first of all, and I would get 3 and say I got 1, 3, and I would get to 2 and say I got 1, 2, then I would get to 3 and say I got 2 2s, 2 3s, and then my answer would be 3 because I have amount of 3s that's more than half the array. And then with nums, with the second example 2 nums, I would go through and count the same way. I would keep track of what I'm counting. How many 2s did I get? As I go through, I would just add a count for each thing that I find. And when I get to the end, I would look at the counts that I've stored, and I would pick which one is the highest value, or I would just pick the first one I find that is over half the length of the array, like the length of the array divided by 2. So with that being said, when I think about the problem, the data structures and algorithms that could help me with this, automatically whenever you're counting something, the thought process once you do a few of these problems goes to having a dictionary, which somebody said in the on TikTok here. They and it looks like on Instagram too. Nobody on Instagram said it, but on TikTok somebody said it using a dictionary, or using some sort of map to store the frequencies is what I like to call it. So this problem lends itself to using a map data structure, or some languages call a dictionary. In JavaScript you can use an object as a map, but or a hash map is another name in some languages, and in some lingo that people are using in these interviews, in these type of questions. So we're going to use a map, and I'm going to loop through the array, and every time I see one of these things, I'm going to add them. If it's not in the map, I'm going to add a new key based on each number, and then I'm going to put the count with it. And every time I see another value of the same element, the same number, then I'm going to add 1 to the count. So basically I'm going to have a map that has the count of all my 2s and the count of all my 1s. And in this example, it would have the count of all my 3s and the count of all my 2s. And so I would just loop through, just like if you had a piece of paper and you were at a work site and you were counting the number of blue cars that went by and counting the number of red cars that come by, and you simply mark off, you put red and then you put blue, and then you tick off how many count you have for both. We're going to make a data structure that can save our count of all the numbers, and at the end we'll figure out which one is the majority element in this string. So without further ado, this one's pretty easy. Let's jump to the code and try to solve it. And I actually haven't ever solved it this way. I actually jumped to a different solution, but I'm going to try to do this in real time. Hopefully it's not crazy. So to start, I know I need basically like a count map that's just going to hold my count, or like a frequency map. And in JavaScript, it has a map object, but you also can use it has a map like data structure, but you also can use a pure object as a map as well. And so the next thing I know I need to do, oh, hold on. The first thing I want to do is actually put this over here for people that join late so they can see what we actually doing. So yeah, here I also do want to say that like LeetCode, go ahead and like give you this function stub. So we know we have it's called majority element, and we know that it passes in nums. The nums is an array of numbers, and we know we need to return a number, which is the amount of the number that's the majority element in the array, the numbers array. So I'm gonna put this here though, just so people know what the problem is. Yeah. Okay. So yeah, I'm gonna create this count map first to hold my frequencies, or I might even call it like frequency map or something like that. And so then I'm gonna loop through my numbers since I know it's an array, and basically if the frequency map, I shouldn't have spelled frequency every time now. If the frequency map has n in it, then I'm just going to dang, I don't know why I typed this frequency map thing. I'm going to add to it. So this plus plus will just allow me to add to it. This is just a loop for anybody new to programming. This is allowing me to loop through the nums, and each num will be assigned to this n, and I can basically inside of this loop, I can do whatever operations to that element inside the array. The first thing I'm doing here is using an accessor to the frequency map for n, which is the number in the array. And I'm saying if I have, this is basically like a Boolean check. If there is a value already inside of the frequency map for the key called the whatever number that we're currently on, then I want to take that value. This actually pulls the value out again, and then this actually adds a 1 to the value. And if I don't have that in the array frequency map already, then I actually want to just set it equal to 1. So I want to just set it like initially to something, because you have to set it in the map first in order to later like add to it. So it's probably like a shorter way to do all this code, but like this is the most expressive way I think to write the code out. So yeah, so that's basically getting me a frequency map. So let's recap what we done, and let me see if there are any questions that popped up. PhotoLogic said it makes sense. Glad it does make sense so far. Somebody said I got to do LeetCode challenges every day. Can you show the question with the code, please? Yeah, I added it. Thanks for mentioning that. Reduce method. Yeah, you probably could do something with reduce, but a lot of times I try to avoid using like some of these convenience methods in the language, because if you do use something like that, you need to be ready to explain what's happening behind the scenes. Like if you use reduce or filter in JavaScript, you need to be able to like explain like what is the complexity, time complexity, and space complexity behind the function you're using. And they may just tell you straight up, hey, don't use that. Like, because, not that it's cheating, but they'll just be like, hey, can you do this without using built-in like convenience functions? So anyway, what we've done so far is we've taken our number, we've built the frequency map by looping through the numbers and using, I didn't explain what a map is, but a map is basically key pair values. So you can put in a key and you can have a value for that key. So it's like a dictionary, basically, is another name for it. Like if you go in the dictionary, you have words as the key. So you're looking through a dictionary and you're trying to find keys. And then you look up definitions, like a real dictionary, just comparing it to a real dictionary. And you actually have definitions that are for each of them. So that's the same similar concept with a map. And so for each key, I'm using the number as the key, and the frequency is the actual value that's assigned to each one. And so I'm looping through here and basically counting up, using the number as the key and using the count as the value, and I'm adding to the value as I'm looping through. And so it may seem to some of y'all, it's probably gonna seem like I'm over explaining everything, but like people are at different levels. And also you just need to learn how to explain yourself when you do these interviews. You don't want to over explain, of course, but like you want to get to a point where you're comfortable explaining yourself in front of an interviewer. And it helps you learn. It helps you tighten up yourself on the concepts. Like that's the reason why I'm kind of going into. So I know some of y'all are experts and all that. Y'all know this already. That's cool. You know what I'm saying? So I use var over const. Jess Taylor. Okay. Well, do you know the difference like between var, const, and let keywords in JavaScript? So, and somebody said var is unsafe. I guess it's not necessary. It's unsafe in the sense of like, it's dangerous to use in the sense of like it can make your code behave unpredictably, just because vars are typically they're hoisted up to the global scope or hoisted up to like the top of execution. And so what const does is you're able to set a variable that you know isn't going to change, and so you don't have to worry about the unpredictability in your app if that variable is changed, because it can't be changed. It'll throw an exception if it's changed. With var, since it's hoisted up, if you're trying to use that variable in different scopes, like outside of this function or outside of this loop or whatever, it could have been changed by any other scope inside your app because it's basically being hoisted up. And let doesn't get hoisted up. It stays within the scope of what the let keyword, if you say like let frequency map, doesn't get hoisted. It stays within the scope. So like scope is usually like something like a function scope, like the brackets here, or a for loop scope, or an if statement scope. Like the let keyword would stay within that scope, and you can guarantee some more predictability to your code and maintainability to your code by the effective use of const, let, and var keywords. So yeah, var has kind of like been pushed down as like the option. A lot of people like kind of like don't want to use var because of that unpredictability. Usually either use let or const if the variable does not have to change again. And the reason I can use const on a frequency map is because it's an object, and as long as I don't reassign it, then it doesn't count. It's like what const doesn't let you reassign it, but you can still use the map, and like internally you can change things about the map, but it's still the same assignment to the same object, like in memory or whatever, in runtime memory. So yeah, I'm just trying to explain some little extra stuff here. Oh, okay. Yeah, I see. Yeah, so you've been using Python. Yeah. Okay. I understand. Just, yeah, learning like differences and similarities between the languages is definitely important too. So anyway, I'm gonna get back to the problem. We're in a frequency map. We've looped through and basically built our frequency map. We're not in the frequency map, but we basically built a frequency map that has the keys, which are the numbers, and has the values here. And so what did I say we need to do after that? So we need to find a majority element. So now that we have a frequency map with a bunch of counts in it, we basically need to find the element that is the majority, the element that appears more than n minus 2 times. N divided by 2 times, half the time. So I think what we can do is we need to look inside of our frequency map. So, I gotta remember how to do this. I think what I can do is since this is a map, I need to, like I said, it's keys and values. And so I think I need to get the keys I need to look at every key in my frequency map and figure out which one has a value that is greater than n minus 2. And so I can say key of, and I think this is how you get the keys out of a map in JavaScript, or an object, which an object is like a map in JavaScript. It's key pair parameters or whatever, or like fields inside of the object can be thought thought of the same way and used the same way as an actual map in JavaScript. So I think this is the syntax to get the keys out of a map and as an array. This is stuff you just gotta know. Like whatever language you pick to do these coding challenges with, you need to have that part memorized, like syntax. Now I'm kind of tripping because I'm kind of like forgetting stuff, and I'm like it's not on top of my mind. But if I was being interview ready, you need to have all this stuff at the top of your mind. Like you don't want to get tripped up on trying to figure out syntax and stuff. Like, I mean, maybe a little bit is fine, like typo and forgetting little things, but you don't want to get like majorly stuck on like trying to figure out stuff like how to get the keys out of a map and stuff like that. If you do, now you're not even answering the problem. You're stuck on something totally different. And so, yeah. And somebody said, why are you using var? Where am I using var at? Oh, I'm not. This is LeetCode did that. So, I mean, I can change it, but I didn't do that. So LeetCode stubbed all this out. So blame LeetCode for that. I didn't type anything var, but I changed it now. So cool. Yeah, I didn't do that. I don't know, but LeetCode might, because LeetCode has a runner and it might need this to be a var. I don't know, but LeetCode did that. I didn't do that. So, but good question though. Good catch. I get it. Like you asking because you saw it, but I didn't do that. LeetCode did that. So anyway, yeah. So I'm looping through the keys in the frequency map, and I basically need to check the frequency map at the key. I need to go back in the frequency map and add the key. That's how you pull the value out of what that key is. And so basically what I'm trying to see is based on my key. I'm trying to find the key that has, like, if this key's value is greater than, and it says appear more than half the time. So basically I need to like find, like, I guess what, this is a const. So what is half length? I guess, I hope this works. And I guess I'll take the num's length and just divide it by 2. And so what is half length? And then I would say, is the frequency greater than half length? I actually don't know if this is gonna work, but we'll see. And then return that key, because that would be my number here. And so if I don't get that number, and I might actually do it like this instead. I might say let result equal, I don't know, -1, and then set result equal to key, and then return result. I might do something like that. You know what? I'm just gonna return it right here, because making an extra variable, and then I'm going to return -1 here. Making an extra variable is just giving me more operations than needed. You know, I would probably do it like that if I was coding for a company for readability, but like for optimization, like if I'm coding for a company and they really care about, like, it's really critical, every single operation you're doing, like you're using some sort of resource, expensive resources, then yeah, you kind of start caring about that stuff. And this is what these problems is really trying to get at, is like optimizing code and algorithms to, you know, reduce load and, you know, bugs and all kind of stuff like that. So yeah, let's see. So I think this is where I'm at. Like, I think once I find the first frequency value that is greater than half the length of the string, then I think I have my answer. I don't have to keep going. And that's why I want to just loop through, find the one that's bigger, and then just get out. Like, I'm just done then. Because it's always the one important thing in the question. I think it's up here actually. Now, yeah, you may assume that the majority element always exists in the array. So I don't have to worry about the case where it doesn't, because it always does in our test cases. And so, yeah, so then what would happen from here is, let me think. What would happen from here is, if I was in an interviewer, sometimes they have a runner like LeetCode, and you would be able to run this code, like just keep running it. Other times you would have to, they don't. Like, there's been interviews I've been in where they just give you a notepad and they just give you, nothing. They want you to explain through the problem and walk through the problem, explain it to the interviewer that your code works by running through the actual problem. And so I've done this before. This is how I usually do it. So I would say, so I already kind of explained it to y'all. Like, I would explain to the interviewer like what I'm doing as I'm doing it. So I kind of explain that. But after, if they don't let me run the code, then the only thing I can do is literally trace through my code. So what I like to do is just create comments and put each of my variables in here so I can track what's going on. So like, yeah, we have a key, and then we have like n, whatever n is, and we have a frequency map, and yeah, we have half length. So I just write down every single variable here, and I'm gonna try to go a little faster here to get through this so I can maybe answer some questions at the end. So, but yeah, so then I'll take one of my, let's take 3. I'm gonna go with a short thing here, because short like a test case, so I can get through it faster. So let's pretend our test case is 3, 2, 3, and we know our answer is 3 because that's over half the array. So, and I know we have a frequency map that's gonna look like that. So we'll just walk through the code. So first line, we set the frequency map equal to this. So I did that here. Second line, we start going through nums. The first num is 3, so n will be set to 3. And then in the frequency map, if it has n, frequency map has 3, it doesn't. Then we go down to this line, we put n, which is 3, into the frequency map, and we set it to 1. So let's do that. Let's put 3 in and set it to 1. And then we loop back to the top here, which now n gets changed to 2. So n is now 2. Is it in the frequency map? No. So then we add it in with a 1. So now you just put 2 into our frequency map as 1. And then we loop through again. N is 3. Is it in the frequency map? Yes. So then we get to add it to what's in the frequency map. What's in the frequency map for 3 is 1. So we're basically just doing plus plus, which adds 1 to it. So now 3 is 2. And so this frequency map is perfect now, because we know we got an array with 2 3s and 1 2. And we have a frequency map that says 3 has 2. There's 2 3s, and then we have 2 key. The value is 1, saying there's only 1. So we basically have a frequency map or a count map is what you can call it, either one. And so now we get down to our code down here, which basically says loop through the keys inside the frequency map, which are 3 and 2. And so then we're going to find, you know what, this actually... See, this is why you walk through this, because you actually find issues. This actually doesn't need to be calculated every single time. It can be done beforehand. So half length, our num's length is 3. 3 divided by 2 is 1.5. And shoot, I hope that'd be 1.5. I don't think this will have any issue doing this division stuff. So that'd be 1.5. It's half the length. And I think, I think I might have to do I need to do any rounding or something with this, since the array is odd? I'm thinking maybe I have to round down. I might need to actually round this down. I don't even know. Or maybe not. I don't think so. I'm not going to do it. But anyway, I'm probably maybe overthinking that. What do y'all think? Math floor. Yeah, I might do that. I'm not gonna do it actually. I'm gonna just see if it works without it, and if not, then I'll go ahead and do it. But that's got me overthinking about that. But anyway, it's 1.5 if it's since it's odd, and it'll go decimal just because it's an odd number being divided by 2. So half link is 1.5. Then we'll go into this. So then the first key is 3. So let's set that to 3. If the map has 3, or sorry, for the map value at 3, which is 2, is it greater than the half length, which is 1.5? And yes, it is. So we automatically return this key, and our key is 3. And so we're going to automatically break out right here without even going through the rest of it, which is wise to do. You want to break out as much as possible to kind of optimize your algorithm. And so then the result, or the return, we're going to return 3. And what was our answer over here for that? Is 3. Output is supposed to be 3. So as far as me running through the code, everything seems to work. Now, what's funny about this is what happens sometimes. I feel like to me in interviews is if the people don't make you run it and they don't see any issue with your solution, it could be wrong and not work. But because you don't run it, if you explain it to them well and they understand and they believe you, then you actually could get away in some interviews. It's like the double-edged sword of those interviews where they don't actually make you run the code. Like if your solution looks good, sometimes they've seen it so much they can tell when you messed up. But sometimes I've been in interviews, I've done problems, and I've done it later after the interview. It's like my solution didn't even work. But they were looking more for how I problem solved, how I came to my solution, the way I coded, and not for like perfect, like if there's like some sort of bug in it. And so that's why they don't let you run it. That's their whole point, is it ain't about just running it and getting perfect code, and just like it's about trying to like see how you think and how you problem solve. So yeah, somebody said I graduated in December and I'm so scared. Hey, I was scared too. I was scared of these interviews after I already had a job. I had a job for like years and I had never done one of these interviews because back when I first started, this wasn't like super prevalent at most companies. It was only prevalent at like the big companies. And then as I got like 5 years of my career, everybody started doing it. Even we started doing it at my company. And so I had to learn it, and I was scared too. And I had experience, but experience don't mean nothing for this stuff. Like this is a different beast that you have to tackle. But at least you're coming out of school, so you've probably had some recent experience with this in school. Like for me, I did all this in school, forgot it all over the 5, 6, 7 years, and then had to go back and like kind of brush up. And then on top of that, had to learn these like LeetCode coding challenge tricks and all that stuff. So anyway, I'm gonna stop talking about that. So yeah, as far as me running through it like that, it seems like it's working. So now I'm going to LeetCode actually does let you run, and some interviewers will let you run the code. They'll be using HackerRank, or I've never seen one actually use LeetCode, but I've seen them use HackerRank because it has like an interviewing section to it. And I've seen them use other tools, like their own internal tools before as well. So yeah, let's try to run this and see if I get an error or something. All right, man. That was good because I wasn't sure. So these 2 test cases work. I'm going to throw another test case in here. So the only test cases they got strangely on here is like only with 2 numbers. So what happens if we have like 3 numbers? Shoot, where the heck do I add more test cases at? Oh, here. Yeah. So let's add, and I want to see what it does when it's even too. So, and I can't do one with equal with like out the being a majority, because remember they said every time there should be a majority. So, yep. So case 3 works. Let's add another test case. I want to add another test case with a third number in there. So let's say there was a 3 up in here. Let's say a 3 at the end, and then there's a 2. So 2 is still, oh shoot, no, it's not gonna be the majority number anymore, I don't think. Let's see. Will it? One, so it's 4 2s, and yeah, it's not a majority. So I think I have to add another 2. I think. Yeah. So then it's 5 out of 9. Yeah. So let's see if that works. My algorithm works. Yeah. So it still found the 2, even though I had a third number in here. So yeah, this is looking pretty good as far as this solution goes. This is, for anybody just joining, this is the problem. Basically, I needed to find out what the majority, in each of these, I need to find out what the majority number is, the one that occurs more than half the time in the array. And my algorithm seems to do that. And so the next thing an interviewer would expect you to do, or either ask you to do, is determine the space and time complexity in big O notation. So big O notation is basically a guideline to help you express what the complexity is based on time and space that's used of the algorithm that you wrote. And big O notation is directly tied to the input size. So that may mean the number of letters in a string. That may mean the number of, in this case, it means the number of numbers in the array. It's always tied to the size of your input. How does your algorithm scale in complexity and in performance based on the size of the input? When the input goes way up, does your algorithm perform worse, or does your algorithm perform like linearly? Does it not matter how much input comes in? Because that's a decent algorithm. If you have one thing and a million things you have to process, does it still perform well even with a million things? Versus a worse algorithm that is fine when you have 5 things, but once you put a million things in it, it like exponentially performs worse. Is that the case? And so that's why they ask these problems for these big tech companies. That's at least originally where it came from, is tech companies like Google that actually dealt with problems with scale, where a programmer could write a bad line of code that could cost them hundreds of thousands of dollars because it was exponentially bad algorithm that cost them, like pretend like the frequency in here was like money, or I don't know, like pretend like every time I had to check the frequency, it cost the company money because we're hitting some database or something somewhere. So like the more optimal my algorithm is, the better my performance is, and it can actually save companies real money. Now the leak code and challenge thing that went to a level that they probably didn't even expect. It's been super gamified now, but I feel like, at least from what I know, that was the original kind of purpose, to kind of turn it into an interview form of the principles behind it, what it was, but they turned it into sort of like a gamified interview form. At least that's my thinking. Whittington is on here. What's up, man? He's talking about my middle name is KG.codes. Bro, you crazy? Yeah, and then somebody said click submit. So yeah, I'm about to get to that, but let me talk about space-time complexity first. So time complexity of this, I didn't even think about it. Time complexity. So like I said, it's based on the size of the input. So the thing that makes sense, they've already given it to me, but like most of the time we represent the size of the input is n with big O notation, and here they already gave it to us. They said the array size of the nums array is n, so just call it n. So let's call that n like they are. And one thing what operations are we doing that are tied to the size of the input n? This ain't really, at least not yet, is not tied to the size of the input. It's what operations we're doing. It's not tied to the size of the input. We always, no matter how big the nums are, we only run this line one time. Like we just run it and set up the map. But here, when we get here, we're looping through the num. So if it's one num, we loop one time. If it's a million, we loop a million times. That means every operation in here, we would do a million times in that case. So that's tied to the size of our input. But it's tied linearly to the size of our input. So for every n that we have, we're doing n operations here. And so we already know based on big O complexity that we're doing n operations at scale. Operations that just happen once, we call those constant operations. And in big O notation, those can be reduced out of the final big O notation, if that makes sense. So like right now we have one constant plus n operations here because it's going to loop n times the number of elements we have. This constant operation, it just happens once no matter how many we have. Now this number is going to be bigger, but it's still like division is just a single operation. It doesn't matter how big this number is unless it like overflows or something. But based on our constraints, it shouldn't overflow. And based on our language, it shouldn't overflow. So then here we get here and we have a number of keys. And so this number of keys, this is actually interesting because this number of keys is actually not the same number of items, but you have to think about it in the sense of what can it be. Big O notation needs to be at worst case. It's always at worst case. So worst case, let's say I had let's say I had the 4 2s I needed here, and let's say I had 3 other numbers here. At worst case, it's always going to be less than n. It's always going to be less than n. So in that case, we basically could say it's never going to be any worse than n. So it's like slightly under n because we never can put more keys in the frequency map than numbers of things we have. So we can kind of like reduce this or like assume that this is the same as n. Some people might come here and call this like a different variable, but they may say this is like the distinct number of keys in the array. I'm not going to do that. I just always know that at worst it can be like half of n because like half the array always has to be the same thing, and then the other half has to be different, can possibly at worst case be different numbers. So I always have as many keys as that. And so I'm just going to assume this is n. I don't know what the real answer might be. N plus like if you give this a variable name m. But I'm going to just treat it as n, and I'm going to say basically for the whole, and then this is constant too, so it reduces. So if I say n plus n, when you add together, that's basically considered a place where you can reduce in big O notation as well, because it doesn't substantially make your algorithm performance go down to add the same amount. Like, so if we have 5 things in our thing, then if we have 5 numbers, then this will go 5 times and this will go 5 times. And if we had another loop, it'll go 5 more times. But that's not considered an exponential like jump in number of operations. It still reduces down to n because you're kind of like just adding one more loop through. I know it can seem like once you get to 1 million, the difference between 1 million and 2 million seems like a lot, but it's a lot better than if it was 1 million times 1 million. So that's why in big O notation, it kind of just reduces down, like addition just kind of reduces down to being nominal. Like it doesn't really mean as much as being multiplicable. Man, how the heck do you say that? I don't know, but you gotta know what I'm talking about. So anyway, that means I know I'm being long-winded, but I'm just trying to over-explain to y'all. That means the time complexity is big O of n. And then, so let's talk about the space complexity. So the space complexity would be basically any data structure that is affected by the size of the input. The only thing affected by the size of the input is nums, which you don't include in the big O notation. But the new thing that we're doing here, that we're actually doing, is the frequency map. That's being affected by basically the size of nums. And so worst case, similar to getting these keys out, this actually might be a different answer. I don't know. It might actually be just the like like n divided by 2 plus 1 or something like that. I don't know. But I feel like all that reduces to just n, but I don't know. But I'm going to just say n because I think worst case, it's the distinct numbers inside of how many things we're going to put in the map is the distinct numbers inside of the number array. And so how much can that be? It's always going to be half of it is always going to be the same thing. And the other half is can be, at worst case, it can be different numbers. So like in this case, it's always going to be like at least all these 2s, but like these 1s could be 1, 2, and 3. It could be like 4, 5, and 6, 7, 8, 9. It could be all these different numbers. So it's always going to be like at least half the string out of n, which is the length. It's at least going to be half of them are going to be the same thing, and then the rest of them are going to be this different value. So as n grows, I want to say it would just be n, like big O of n space complexity. But I could be wrong there. Y'all let me know what y'all think. But I'm going to say space complexity big O of n as well. So yeah, that's that. And the last thing I'm going to do is somebody asked me. I know I know I suck at reading the comments and stuff like that. I appreciate y'all listening and holding on. It's hard to do these problems and like do comments and do all that stuff too without like taking too much time. So anyway, the last thing I did, I ran it against these 4 test cases. I added my own. I was successful. The last thing we can do is run it against LeetCode. Lets you run it against like all their test cases. They have a lot more test cases and they have a lot more strenuous test cases with like hundreds and thousands of input to see how it performs. And they also compare it against other submissions within LeetCode. Like how did you do against other people using LeetCode? So I'm running out of breath, but like let's run this and see. So it looked like it got accepted and beats 85%, which that to me seems kind of weird, but no, I guess it does because it's trading space for speed. So I'm using that map and it's helping me with the speed. Now let's analyze the complexity and see. Yeah, so big O of n, I was right with the time complexity. I don't think LeetCode, I think they're using like AI to do this, and I don't think they have space complexity on here yet. But it'd be cool if they got that. But yeah, it's pretty good. 8%. Oh, they do have it down here. My bad. Why was it? It was like invisible. So I only beat 8% with space complexity. So I must have could have done something maybe better there. It's big O of n. It's two. But you have to take these with a grain of salt. Oh shoot, y'all can't even barely see it. Y'all had to take these with a grain of salt. But at least from what I can tell, I got them right. But I didn't even check this when I did the problem last time. So. Whatever. I'm gonna go with it. I'm gonna take my win while I can. So yeah. So one last thing I'm gonna do before I get up off of here. Somebody said initialize the half link before the first loop. Does that change anything? I don't think it. So just put it up here. Initialize the half link before the first loop. Move that in the second loop to the first one. I don't think I can do that. Maybe explain what you mean with that one. I don't think you can do that. Yeah, somebody said move. We didn't see the time complexity. My bad. You can have that if statement in the second loop and the first loop. I don't think so. You got to build the map first. You need to build the frequency map up first, and then you need to loop. You need to loop the frequency map to see where the frequency is. Oh, I see what you mean though. Yeah, you might be right. No. I don't know. Yeah, no. I think I see what you mean. Yeah. You might be right that I can move it up there because if I get a frequency, yeah, that's a good idea. You might be right. Let's try that out before I hate on the solution. So move half link up here. So I already know the half length. Sorry. And then yeah, I guess if yeah, shoot, I think you're right, man. Yeah. Then just move this up here. Yeah, shoot. Yeah, I think you're right. Thank you. I didn't even think about doing that. That's smarter. So then I don't even have to do that second one, and I don't even have to finish the this loop. Like if I find, as soon as I find the first frequency that's added up to over the half length, then I just return the key. But here I need to do n, and I need to return n. And let's try that out. Who was that? Let me see. A. Lee. Appreciate it. Appreciate you saying that. Yeah, so that worked with that. Let's see. Submit. I'm gonna submit it to everything. I don't know. For some reason it went. You gotta take these with a grain of salt, but I expected that to be better for some reason. Time complexity should be the same. Oh shoot. Hey, I can't do this no more. That's stupid. It's talking about I need an upgrade to Pro. I didn't know you can only use it twice, I guess, a day. But the time complexity, even though we changed the solution, it is more performant for sure. It is more performant because in certain cases, it will allow me to break out of the loop faster than I was before. I don't wait till I get done building the frequency map. I just can just break out whenever I find a frequency that's higher than half the array, just leave out, and it allows the algorithm to work faster in certain circumstances. So hey, appreciate that, man. Appreciate that. Change the keys to n. Yeah, I appreciate that. Yeah, but yeah, somebody said there'll still be big O of n, but it is a more optimal solution for sure. So I appreciate you saying that because I did not get that. And so the reason why it still stays big O of n is just because it's big O of n is measuring, big O notation is measuring worst case. So worst case, I may not be able to like break out of this until some test cases. I may not be able to break out of my array until like the last actual thing. And so worst case, I would still have to go through every single element in here until I got to the frequency that added up to here. In worst case, that's only in some cases, but A. Lee's solution allows me to, in a lot of cases, break out faster and save on operations. So I think this thing just shows different results for some reason. Like it may show a different result this time. Let's see, because this should have been faster. Yeah, so it went up to at least 80 again. So I mean, that's how stupid that thing is. Like it went from 60 to 80. Like it's just not really reliable. So anyway, great solution, man. Appreciate you saying that. Yeah. So I guess I could have just gave it to ChatGPT, but I'm not gonna do that because I need to go in a second. And what I'm gonna do is now I gotta figure out if I'm gonna be able to do this solution in a good time. So I'll get back. Yeah. So they said at the end of the problem, can you solve this problem in linear time and in big O of one space or constant space? So I did solve it in linear time. That's big O of n. But can I solve it in constant space? Is the follow-up. And in the interview, if they ask you an easy problem like this, because like honestly, if I just doing this, I would have done it like 10 minutes or 15 minutes or whatever. And so they would ask you a follow-up to kind of make it a little bit harder, to put a little bit more effort onto it. And so how can I do that without, basically they're saying to use constant space. So what that means is that I can't use a frequency map that is growing with the size of my nums. So I really just can't use, the only thing I can do is just set up like constant variables. Nothing that actually has any alignment with the size of the input. I cannot store anything. And this is a real problem in some applications. Like I've had applications at work that have they use runtime memory. Whenever you set up a map like this, you're storing You're using up like RAM on the machine. You're using up resources on the machine that can be valuable. And once you scale up to 1 million users, you're storing, 20 kilobytes per thing you're storing or more. And then next thing you know, your server runs out of space. You need to horizontally scale, or you need to vertically scale, whatever you decide to do. Add more RAM to the machine, or vertically scale the machines to more machines that run at the same time. That costs money to do, no matter if you're paying for cloud or you're self-hosting, or you're, any combination, hybrid or whatever. It's going to cost you more money to do that when you simply cost you money, but it's like a one-time thing. You go, cost you dev time to somebody go fix it, but they fix the bug, make it more optimal, save on memory. And so that's why they ask these problems. Like, it does have real application. It's not just all stupid questions and riddles and games. Like, it does have real application. Like, I've seen it have real application. I've wrote bad algorithms. I've seen people write bad algorithms. I've seen somebody write an algorithm that was looping a database and basically just took down the database because it just was going just nuts, like where they didn't even need to do that. It just kept going back to the database like ridiculously. So it matters. But anyway, so let's try to figure out how to do this. I'm like rambling, but let's try to figure out how to do this without a frequency map. So this is where I got when I watched Greg Hogg, I think, do this. That's where I got confused. Is like how to do this without a frequency map. So, and shoot, now I'm getting confused again because it's like it was not totally intuitive to me how to do it. But when he even said the solution, because all he did on his post, he's doing them real quick. So he's just really he's telling you the problem, going straight to the solution. Great content, dude. Like, follow him if you, I think he's on like Instagram and YouTube, named Greg Hogg. He just goes straight to the solution. He doesn't explain all this stuff. Maybe you want that, you know what I'm saying? That's cool. I do that too on my channel, but I like to do these lives too. But anyway, like, basically the solution is to avoid creating a frequency map. How can you keep a count of these? You got to count these up and figure out which one is the majority one, which one which one occurs more than half the time. How can you do that without counting up the twos, counting up the ones, counting up the threes, counting up the twos, whatever? How can you do it without that? Well, what you can do is you can try each of these as a candidate and keep a count of them one at a time, basically. And so when you can loop through the array like we did, and you can say 2 is our first candidate. 2 might be the majority element. We know we guaranteed to have a majority element because it says we guaranteed to have one. So we know we know one of these is going to be the majority element. So we can all count them all as candidates. Let's go through and just say 2 is a candidate, and just say, okay, we got one of our candidate. And then we go to 2, we say, okay, is 2 the same as our candidate? Yes, we have another one of our candidates. So let's make the candidate count 2. And then we get to 1, and it's not the same as our last candidate. So what we can do is we can say, like, basically our candidate is, the count of our candidate needs to be more than everything else. And so when we find something that isn't a candidate, we basically can subtract that from our count. And so let's say we subtract 1 from the count. So now we only have 1, and we subtract another 1 from the count, and now we have 0. And so once we kind of like have a candidate, and when something's not the candidate, we subtract from our count. When something is the candidate, we add to our count. And if we get to 0, that means something else outdid our candidate. So like, let's say we got 2. Let's say our candidate is 2, and we count 2 2s. And then we see 3 1s that aren't our candidate. Once we get to this third one, we've kind of outdone our candidate count. And we basically, if we subtract while we're finding different things, we'll get down to a count of 0 with this candidate count. And we'll basically know that, okay, or we'll at least think at the time that this isn't the true candidate. And so what we can do is set 1 to the true candidate, and we can say, okay, we got 1, 1. But then we see a 2, and we're like, well, dang, 1, this is different from the 1. So then we subtract from that candidate's count, which is 1. And then we see a 2 that makes the count as 0 again. And so we set 2 as the candidate. And so basically this algorithm, by the time you get to the end of it, it gives you the candidate that has the most, because you guarantee the majority is always going to be in there. So like if you do this algorithm, it always will give you the majority count. Now, to me, that's not intuitive. It really isn't. Like I just can't see how somebody could have this is LeetCode.com. Somebody asked, what site is this? But like, I don't see how you could get to that on your own just from just intuition and never having done these problems before. I've done a lot of these problems, and I wouldn't have thought of that off the bat, like that type of solution. And why is it saying I need to verify this live? Like, it's stupid. Yeah, but anyway, yeah, so it's basically saying that, oh, dang, Lawrence D.codes, man, if you still on there, what's up, man? What's going on? That's my dude, man. Anyway, yeah, it's basically, I don't even know what I was talking about, but, yeah, it wasn't intuitive to me, but I mean, maybe it's intuitive to some. Y'all let me know what y'all think, but I'm going to try to do this solution. I'm going to try. Let's see if I can remember how to do it. So two things I was talking about, and like we talked about earlier, we can use our let keywords instead of var. I have you know what I'm going to call this? Candidate count. And then I'm going to call this candidate. Yeah, I'm not going to set that to anything. So this is the candidate, and then this is the candidate count. And I'm going to delete all this in here. And I'm going to say I'm going to return my candidate, because once I get to the end, I'm going to know my candidate is right. And so what I want to do here inside my loop now is, like I said, I want to basically, if n is equal to the candidate, then I want to add to the count. Else, if it's not equal to the candidate, I want to subtract from the count. So I basically want to keep a running total of my candidate, but if I'm not seeing, like if it's not my candidate, I'm not seeing my candidate, then I'm going to take points away from that candidate, because that candidate, if I'm seeing other stuff that's not the candidate, I'm going to take away points from it. It ain't really it's hard to explain even. Like, this solution is really, to me, hard to explain even too. And maybe it's easy for some folks, but like also you see here, I'm not using any data structures that are tied to the side. I'm just simply setting these constant variables. Everything I'm doing here is basically setting constant space. Like, this loop is time complexity, it's not space complexity. So they said do linear time complexity, so I'm still doing that, but I'm only doing constant. Everything I'm doing here is constant. So if I had a million things here, I'm not going to be using, the only thing that's going to be using space is this nums. But like, as far as me, I'm not building any new data structures that are causing to be populated with like a million things. Everything's just getting populated at runtime, and it, every time it loops through here, it'll lose its context or whatever. So yeah, that was the first thing I'm doing. Is I'm going to add to the count when I see the candidate, and going to delete from or subtract from the count when I don't see the candidate. The other thing I have to do is the first time, like I said, if the count is 0, then I need to change or set the candidate. So here I'm going to put a space between these. I'm going to set the candidate equal to n. So I'm going to set a new candidate. So like, when it first loops through, then this count is always going to be 0 to start with. Oh, my bad. This is not count. This is candidate count. I'm going to just call it count. Y'all know that it's the candidate count. Yeah, so candidate count. And yeah, so yeah, if it's 0 when it first starts, then I'm going to set the first candidate. But basically, if I have a candidate and I've added it up with everything I see, but then I see other things that aren't the candidate, then that knocks that candidate's count down. And once that candidate's count is to 0, then just try a new candidate. And so, that's the new solution. And because I'm not using any space, it makes the space complexity go down to constant space, which is a much better space complexity. It can save you money if this algorithm actually was doing something that took up valuable resources to use up space for whatever the reason. So like I'm not gonna walk through the code like I did last time. It's gonna take too much time, but I'm just gonna run this and see if it works. Yep, so it worked. So I mean, this one actually probably would have been better for me to run this one, because this one, unless you run through it, like it's to me, it's a little harder to understand than using the hash map and just storing the frequencies. Like, because you're trying to not use a hash map and you're trying to do it at runtime without actually storing any data to help you. You're actually trying to just keep track of everything in single variables where you're at inside of the loop. And so that's when you kind of reach a more optimal level of doing things. And that's when the LeetCode problems start to get a little bit more difficult, where you're trying to like save space, because a lot of times space helps us optimize our algorithms. And so when you can't use it, it makes the problems a little bit harder to understand to me, because you kind of got to like keep track of stuff. So yeah, this part right here, man, this was the part that wasn't really intuitive to me, like this subtraction adding thing. But it's because you can rely on this so much because of the fact that the majority. Now, if this problem said find the thing that occurs the most in the string, you couldn't do this. It's because it's always the majority. And so because you're counting up the thing that's the majority, the things you're going to subtract from the majority are always never going to add up to the amount, because everything else in the string is less than half of the string, if that makes sense. So everything else that isn't the majority one is never going to add up to the majority. So when you do this algorithm, you're always going to be left with whatever the majority one is. And so that's the best way I can explain it. It's tough. It's a tough one to kind of understand to me. Yep. And whatever's at the end. Yeah, it's a great approach. I mean, it works well, and it's the best approach. This is the one that is the best time and space complexity combined. Just run it against the rest of LeetCode. I'm assuming it's going to work because my less optimal solution worked. It says the runtime was less. I guess. I don't really trust that thing, but this is definitely a better space complexity solution. It won't let me read it out, but I could probably put it into, I don't even need to put it in Chat GPT. I can tell, you can just look at it. It doesn't use any maps. It doesn't use any objects. It's just simply setting integers the whole way through. It's just setting integers and adding stuff. It doesn't use any space as associated with the size of here. It does remain with one loop, like my solution before did, and like the one a lens or whatever added. So yeah. So this is kind of where we're at with this one. This is the better solution. Lee said you could put that if statement back in from earlier to save time. I don't know if you can do that on this one. Nah, maybe I'm wrong again, but I don't know if you can. You might. I don't know if every solution would accept that, like, because I don't have a count of everything. So like, let me see where it is. I don't see where I could like break out of this because I don't have a data structure to break out with. So I can't even use the same if statement from last time. I don't have a data structure. So I guess I see what you mean. I can use candidate count to break out if I have a candidate count. If I've like counted already right here. Yeah, so wrong again. Yeah, I see what you mean. Like I can if the count is at some point greater than that same thing we did last time, nums.length. I don't remember what we called it. Yeah, I think we called it half length nums. So if, yeah, and that needs to be divided by 2. Basically what we're doing is just getting the half of the length and just breaking out early if count is, let me see when I need to do that. Yeah, I guess if we get after here and we add it to it, then really right here, but I can just put it right here. If count is greater than half length, then return the current candidate. So yeah, because this is the candidate count. If it's greater than half length, then return the candidate. Is that what you're saying to do? Let me see if he's still on here. If candidate count is greater than num size divided by 2. Is probably what you were trying to say. But you, I mean, yeah, you got the right idea again. A Lee. Let's see. Let's make sure it works. I think you're same as last time. Like it gets you out of the loop faster. So yeah. Still LeetCode's kind of tripping on the runtime, but I think it's obviously better runtime, I think, to me. But I don't know if LeetCode is actually using test cases to come up with this runtime, or they're just looking at the algorithm in general. They got to be using a test case, but maybe the test case they're using, because the runtime complexity is the same, then yeah, still the same, because worst case, you still have to get to the end in some inputs. But yeah, very, very good to do this here. Interviewer might ask this. He might be like, can you get out of this early? Or I don't know how they would ask it, but they might ask to look for this. So very important. Appreciate it again. Y'all go follow A Lee. And I don't know if I might be saying the name wrong. Ali. He jumped in this same solution twice when I forgot it twice. So, or I didn't know it the first time and forgot it the second time. So appreciate that, A-Lee. Like, hit up each other, follow each other, all that stuff. I see there's a lot of discussion. I know I missed. Oh yeah, I'm sorry. I'll go to the question again for some people. And let me see if I can like shorten this up so you can kind of see. Shoot. I'll take this out for right now. Actually take this out and like put it on the bottom. Zoom out maybe. Shoot, I'm gonna have to zoom out so far though. Oops. Yeah, so yeah. This is the optimized solution that uses constant space complexity. So I hope this makes sense. This was a long one, but yeah, wanted to explain everything out. I hope this makes sense to people. I appreciate the help for the people that helped me out and brought stuff on. Let me see. Why not sort? That takes too long. Oh yeah. Why not sort? So sorting would be worse than just going through it. I think that'd be in log in, or I guess it depends on what you're using to sort. Like if you're using an algorithm to sort, a built-in function or whatever, but I think it'd be either log in or in log in. It'd be worse than just linear time. So yeah, can you use a map? Yeah, so like earlier you might have jumped on after. I did use a map the first time, but the problem basically has a follow-up. So let me see. if you can look at all my old solutions, and dang, wait, hold on. It's not the right one. Yeah, so here's the one with the frequency map. So you can use a map, but it's not the most optimal solution. The solution is most optimal is the one that doesn't use a map, that kind of like figures it out at like in real time without trying to store extra data. So yeah, turn into a new set. A set wouldn't help here because a set really doesn't help with frequency. It more or less helps with like I mean, maybe you can figure out a way to, I don't know. I'm not going to say that you can't, but I can't figure out how, on the top of my head, how a set would help you with this. Bucket sort, but bucket sort will require in space. A bucket sort, I don't know about a bucket sort. Let's see. Bucket sort, and I mean, it says, Google says it's m plus n. Y'all let me know. It says the worst time complexity of a bucket sort is n squared. N times n. Let me see if I take worst case off with it. N plus k. Yeah, so that's a little bit worse than just linear time, just big O of n. So I know y'all may not be able to see that. I was just Googling what the bucket sort was. So I don't think any of the sorts is gonna be better than linear time. Any of the sorts that you try to use, you literally either have to use a hash map or you have to just loop through and use a count and use like some algorithm to figure out which one is the biggest one. Which is the majority one. I'm sorry, not the biggest one. Want to see you implement bucket sort. Nah, I'm not about to do no bucket sort right now. I've been here for an hour. But appreciate it. Yeah, sort is n log n. Yeah. So sort's not gonna really help. And I'm just reading questions and stuff. Let me see if I have questions on it. KG.codes, appreciate. He said it's dope. I love it. Hey, appreciate you joining, man. Love your content and stuff as well. Let's see. So I'm on everything. I'm on Instagram, TikTok, Facebook, Twitter, X, whatever it's called, YouTube, Twitch. I think that's all of them. Yeah. So I'm on everything. You can follow me or watch these lives. I'm gonna try to do them every Friday. And try to do a different problem. Last week I did a medium problem, but I try to do the easier ones because it gives me more time to like explain and helps, people that are new. But I've done some hard ones before in my history of the channel and of the account or whatever. So yeah, I already did it with a map earlier. So if you want to see the map solution, it's here. The map solution is not the most optimal solution as far as space complexity. So I did it both ways. Isn't this exponential time? No, it's not. It's just linear time complexity because I'm just looping through one time. It's not any nested loops. I'm just linearly, as the problem scales, it just scales linearly with the size of the input. However many things I have is how many times I loop, and that's what Go notation cares about. It's just how your algorithm scales in performance based on the size of your input. So it's just one loop. Constant space. Yes, this solution is constant space. Yeah, I did a solution with a frequency map, which is linear space. And then I did the solution with without a map or without any data structure that has to hold anything as far beyond a simple variable. So it's just constant space all the way through. Do you work in tech? Yeah, I've been working as a software, I'm a senior now, but I'm working as a software engineer for like 10 years now. So had to do these in interviews and all kind of stuff like that. Now I'm not no expert or whatever. I do enough when I'm interview prepping to pass the interviews. That's what I've done. I'm not the best lead coder in the world. I'm not the best data structure algorithm. I don't know everything. What I do is, and I got more content. I think I just shared a video of how I prepare for interviews. I prepare based on ROI. Like, I don't just learn every single thing. I study what the interviewer going to ask. I look at Glassdoor, I look at Blind, I look at all the ways that you can find out what problems they're going to ask the interviewer, and I study those things. And even when I'm preparing data structures and algorithms, I use AlgoMonster to prepare, because it just helps like organize the way you learn and the order in which you learn based on the frequency of stuff that's being asked in interviews. But anyway, yeah, I work in tech, software engineer. I work at like a mid-sized company. I guess it's not a startup or anything like that, but it's not like Amazon or Google or anything like that either. So I did pass some interviews for some of those big companies, but I decided not to go there for various reasons. So what's your favorite lead code question? Shoot, I don't know if I even got a favorite. That's a great question though. TikTok by Leah. It's a great question. What's my favorite one? Shoot, I don't know if I have a favorite. I like this one with these phone number combination. It's a lead code hard, but it's like you get like 7 numbers, and it's like find the number of combinations that the number can be dialed in or something. The numbers can be dialed in, or it was something like that. That was a pretty cool problem. And then like there's one that's like got to do with the stock market. It's like buying and selling stock, and like it gives you days, and it gives you the stock price on those days, and your algorithm needs to figure out how to best, like, it's not realistic, but like how can you get the best result from the days when you buy and sell, because sometimes you need to sell certain days and buy on certain days to make the most money at the end. And so I thought that was a really cool problem, even though it's not realistic. So that's a great question. Nobody ever asked that. Are you African? I'm not African. I'm just like African American, I guess, whatever. Yeah, I guess Black American, whatever. Let's see. I did the stock problem. It's the greedy problem. So you done that one before. As a software engineer, what data structure do you use? What data structure do you use in a linked list? As a software engineer, what data structure do you use in a linked list? What data structure do you use in a link, or just do I use any linked list? As a software engineer, do I have to use linked list? I wouldn't say linked list as they are known on like lead code, but like a linked list basically is just objects that have pointers or like variables that point to other objects, and they just get linked together based on like references to the other objects. So you might have like a head and a tail of an object, and that tail points to the next object, and the head points to the previous object. And so there are concepts like that I've had to work with in my job over the years in different ways. It's not necessarily called linked list, but there's relationships between data structures and objects for sure in real life working scenarios, which is why they ask these questions like this. How many hours a day did you study for interviews? So I was studying, the last time I had an interview run was I was working my regular day job still. So, and this was a long time ago. And so, shoot, how many hours a day did I do? I don't know, maybe like 2 hours a day. And then on the weekends, I probably put in more time. And then I took probably like 2 or 3 months before I started doing interviews. No, I did some practice interviews. I did some interviews I didn't really care about just to get my feet wet. Because sometimes you got to get in the interview and knock that nervousness off. Because I've seen a lot of people that they had it down, but you get so nervous in the interview that you can't, or you get this mental thing in your head that I'm really in the interview right now, and it just mess you up. And so it's like I had to just get used to being in interviews every time. So sometimes I'll take some interviews, some jobs I know I don't want. And it's crazy because sometimes I'll actually pass the interview and it's kind of messed up because it's like I feel like I'm wasting time. But I don't expect to pass them, honestly. You know what I'm saying? I guess I shouldn't be using them like that, but shoot, they screw over us all the time, man. These companies screw us over all the time. So I ain't gonna feel too sorry. Are you going to Afrotech this year? That's November, right? I don't think I'm going this year. I said I was going, but I don't know. I might go. It might be too late for me to go though, but I might go. I just went to render, so I kind of used up my work. My work pays for me to go on a trip. I might have used up all the money. I don't know, but I may go. I do want to go to that. I've never been, so TikTok by Leah. I know you may. Have you been before? How much DSA or LeetCode is part of the day-to-day experience of being SWE? It's not LeetCode, not at all. I would say like the way it's gamified on LeetCode and the way it's simplified to these types of problems and like kind of like riddles, how they ask them, it's not. But the concepts of data structures and algorithms, I wouldn't say they come up day to day, but they come up frequently. Like when you're coding, you should be thinking about, is your algorithm like, I didn't see a lot of devs talking about big old complexity at work. I don't see them doing it, but it comes up in code reviews sometimes, for sure. As far as your algorithm, they might not say, hey, this is quadratic time or whatever. This is exponentially bad, or whatever. But they'll say, hey, I think you can optimize this by doing A, B, and C. So that does come up sometimes. I wouldn't say it's super frequent. It depends on what kind of company you work for. It depends on the nature and the context of the work. But I have seen where bad algorithms have taken down databases, taken down servers because they use too many resources, where space complexity was too high, where like they were storing too much data and objects, used up the RAM of the machine, made the company have to vertically scale the machine, meaning buy more RAM for the machine, like pay for more RAM that actually can cost a lot of money. I've had seen companies have to vertically or horizontally scale to more servers because of space complexity, basically. How much has being stored is needing to be stored at runtime while the app is processing whatever it's processing. And so I've seen where developers have been able to go in there, improve the algorithms, and save the company money or stop a bug from happening, like some CPU or RAM utilization issue. So it comes up, but it's just not. You're not just leak coding every day. It's a rite of passage to take down a server for sure. You're gonna submit a bug or take down a server or delete a database or whatever at some point in your career for sure. Use a while loop. Why you want me to use a while loop so bad? I mean, I guess I could use a while loop. I don't see a crazy benefit to using a while loop. But I hear you. How often you use Chat GPT or AI is basically coding for you. So I do use AI tooling at work. I do not expose our code to the AI. But I will use it to look up syntax and just similar to like when we used to go on Stack Overflow, we used to go on Google and we copy a snippet of code from there. I will ask it to write some stuff sometimes, but because I can't and I won't give it the context of my code, it actually can't help me as much as like you might think. Like it does. I can't just go tell it and do my complete job for me because I'm not allowed, and I would not do it anyway. Expose my code outside of the company at my day job. And I recommend nobody do that at their day job. This ain't nothing to do with my company, really. It's just something I wouldn't do. Because you give it, it's a privacy issue. The code of your company is a asset, whatever. It's a private asset that you don't want to expose. So I mean, AI does help me, like, especially if it's brand new code, then I can ask it to say, hey, like, give me all this code, or whatever. But yeah, I can't expose after it's in the code base. I can't expose it at that point. Can you explain turning word to code when it comes down to a problem or a coding assessment. That's kind of what I did here. Like, I don't know how soon you joined, but I don't know if you mean what you mean by turning word to code. Like, you mean like turning like requirements to code. Aren't they automating all these jobs? Are you in Rich Off K's? Are you in tech? That's not true, man. I mean, let me say this. It's true, but it's not, there's nothing special about us that our jobs are getting automated. Like, it's really automation coming for everybody. So I don't know if you're saying that like my job is like less safe than anybody else's, is really not. Like, if you're in a skilled position, your job is at risk from AI. So it's not any less for programmers. They're not like coming after programmers saying, hey, your job is more easy to be taken. That's the lie that's kind of out there right now, that like somehow programmer coding jobs are at the highest risk of being taken for AI. It's really not. It's like, I would be scared if I'm doing any data entry type work, or I'm working at a customer service center, a call center, like things like that are being completely taken over by AI. So I mean, everybody's job, unless you literally going out and putting your hands on something, your job is going to be taken by AI eventually. So it's not like programmers are just like, hey, don't become a programmer. Like, because that's what's happening. People getting scared to do programming because they think it's going to get taken by AI. If you think like that, you should be scared to do anything skilled labor. You need to go into a physical trade, like start working on cars and start working on plumbing and electrical and stuff like that. But then I'll say this. Y'all know Elon's working on those freaking factory of robots, and Amazon just bought like 1,000 robots to put in the Amazon thing. So literally the physical jobs, they're taking these robots, putting AI in them, or just, it don't even have to be AI. They're just putting programming in them, and they're taking people's jobs. So like, even an electrician, one day a robot can come to your house and figure out what's wrong and fix your, so like, I know I'm going on a rant here, but like that whole thing with this focus on programmers being like AI taking their jobs, it's just not what we should be worrying about. Like, it's a way bigger worry than that. But anyway, yeah, do not work on cars. Yeah, I mean, like literally Tesla they making robots to work on not Tesla. Is it Tesla that's doing the robots? Yeah, I think it's Tesla that's literally doing the robots. And then Amazon's buying robots to put in the factories where literally like millions of people are working in Amazon factories for the packaging and stuff like that. The warehouses, not factories. Amazon warehouse. They literally filling a whole. I seen a video. They filling a whole thing with robots. Somebody said they worked at. Jesse said he works at Tesla and he's scared. Like, it's coming, man. So yeah. So I think tech is a great place to be in, honestly, because I feel like there's ways for me to pivot to something that can help the AI. You know what I'm saying? At the very least, I can just say, okay, I need to go to a different company. I need to take a different role. Somebody mentioned data scientist. Making sense of data is still a good role. Because there's a lot of stuff. But like right now, as far as it goes, AI, yeah, it's like some fields AI still is struggling with. Somebody just mentioned that. Like, even in my field, like that they had this thing called Devin AI that came out that was scaring a lot of developers. It was literally a AI developer, and then it was doing all this cool stuff, and then like a few months later they figured out that the thing they basically just made it do this video. They had to like fake the video to make it work, so it couldn't even do what it said it can do. So we still got time, and it's still to be seen what this turns into. But I do know for right now, if you're not using AI, no matter what you're doing, you are falling behind. You should have ChatGPT or some sort of Copilot or something, or Gemini or whatever. You should have something on your phone right now. Like, I'm just putting this out there to everybody on the live. Like, put something on your phone right now and start using it every day, no matter what you're doing. You can be using it for something. Start using it and getting used to having AI assisted work, whether it's in your personal life or it's at work. It may be just your personal life, like asking for a recipe or asking for it to give you a budget or whatever the case is. Asking for it to, you need to write a letter to somebody saying, hey, can you write this letter? You know, I don't know. You need to get used to it though. So yeah, will AI get tired of us and kill us? I mean, yeah, that's what the movies say, but I don't know, man. Who knows, man? Who knows? I don't know, man. Yeah, and yeah, like you said, we can't get too dependent on AI, but like we need to be starting to make friends with it, honestly. I wouldn't make friends, probably the wrong expression, but you know, we need to start figuring this thing out, man. So getting used to it, because I think a lot of jobs are gonna become AI assisted versus just being completely wiped out. Like your expectation of what you should be doing in your role, your output is going to be expected to be higher because they're going to expect you to use AI. Not right now, we're kind of in a cool place where like you can use AI and seem like you're like faster than everybody or seem like you're like more productive. But soon that's going to be the norm. That's going to be the expectation, is they're going to be like, why aren't you using AI to write this this thing you're writing, you know, or whatever. And so, yeah. But it still need coaching, man, because like at my job, AI wouldn't work. Like sometimes the right thing to do ain't always the right thing, if that makes sense. Like sometimes what the AI will do, the customer don't want. Sometimes the customer wants the wrong thing because it can be a feeling, or it can be, you know what I mean? I don't know, but sometimes the right thing ain't always the right thing, and you need people that critically think to help work around these things that aren't the right things. Like that's just how it is. Like you've had times that everybody on here that works, you have times when you've had to serve a customer and they don't always want what's the best, most logical option, and you have to make it work. You have to critically think to make it work, and AI has a hard time doing that right now without being coached to do it. Like there needs to be somewhere to coach it. So it's someone to coach it. And if there's a bug on a website, how do you tell a bug from regular functionality, from a feature? There's real humans right now that get confused about what's a bug versus a feature in some cases. And so they expect that AI, sometimes it's a feeling. Sometimes this doesn't, you know, this contrast doesn't look right, or this thing doesn't look right, or sometimes this thing, it behaves, it works. But like, have you ever seen like an AI generated picture that it works? It kind of looks like it's real, but it's something off about it. Like that's how programming is. Sometimes it takes a human to come in and say, that button is slightly up too far. That button is kind of hard to click. Yes, it works, but it's like literally it's hard to click. Like, you know, bugs like that, AI still has a hard time finding, because AI is just going to say, yeah, I can click that. I just clicked it perfectly. It's not going to, unless you coach it to do it, it's not going to know to like, it's not going to be a feeling behind like what's easy to click versus not easy to click. And I just spit all over the phone just then. So I meant what I was saying just then, you know. So, but anyway, yeah, I'm just rambling now. Yes, Cole Mason, what's up, man? Are you on YouTube? I'm definitely on YouTube. Right now, live on YouTube, live on everything, really. So, but yeah, I'm just rambling now. I'm done with the problem. I think I'm probably gonna try to cut it off here because I'm getting hungry and it's late. So I'm gonna enjoy my weekend. I'm gonna try to do these every Friday. So try to catch me back here on Fridays in the evening times. I'm gonna try to do these every Friday. And yeah, I appreciate y'all getting on here. I appreciate the help I got. I appreciate people listening, asking all these questions. Next time I might just do a Q&A so I can just answer questions the whole time. And I also want to do like a blind reaction. I just want to go on blind one day. Some of y'all know what blind is. And just like do reactions to all the crazy blind stuff people say on blind. I think that might be fun. But yeah, like if you're trying to break into this and trying to learn leak code, just keep going. I promise it gets easier. Just keep trying, keep studying, keep learning the fundamentals. Hey, I appreciate you guys. Appreciate you, Cole Mason, getting on here, jumping on YouTube. Appreciate it. Yeah, man. Like follow each other, connect with each other. I know a lot of dialogue in the comments while I was trying to do the problem. Make it a community. Try to help each other. There's a lot of very wise people that I've saw giving comments in here. I appreciate y'all. Follow me on these channels if you want to see more stuff like this. You want to keep up with me. I post content. I do these lives. I try to share funny stuff, informational stuff. I just shared something about on Instagram, at least. I shared something about code reviews today, but I share it on all channels. Yeah, and love to connect with you. Send me a DM if you have questions or anything you want to ask me directly that I couldn't answer in the chat. And shoot, my voice about to go, so I'm out. Have a good night or evening wherever you at. I appreciate you guys, and I'll see y'all next time. Appreciate it.